Good evening, everyone. Welcome all to this session of Research Scholars Day 2021. RSD 2021 has started with a variety of events ranging from lecture series to interactive talks and workshops to competitions. It aims to bring together great minds from different backgrounds and facilitate exchange of ideas and research interests. We welcome all the participants to the keynote lecture session on Future of Space Transportation by Mr. Jim Cantrell, the co-founder and CEO of Phantom Space Corporation. It's a great pleasure and honor for us to have Mr. Jim Cantrell here in RSD 2021. Welcome, sir.
Thank you.
Here is a short intro about the speaker. Mr. Jim Cantrell is the co-founder and CEO of Phantom Space Corporation. He is the co-founder of several entrepreneurial startups, including Vector Launch, StratSpace, and Vintage Exotics Competition Engineering. Mr. Jim Cantrell has played multiple roles and worked in multiple environments throughout his career. He completed his BS and MS in Mechanical Engineering from Utah State University. He worked as a research engineer at NASA Jet Propulsion Laboratory, where he worked on Mars exploration missions. He has worked on a joint French-Soviet mission in a French space agency. He has experience over 46 satellite missions. He then worked on several joint missile defense programs conducted between America and Russia. Mr. Jim was one of the co-founders of SpaceX, serving as the Vice President of Business Development. He helped the development of Falcon 1 launch vehicle. He has pioneered the concepts of micro launch vehicles and space situational awareness sensors. He has served on corporate boards of several aerospace companies. He also has a deep interest and actively participates in road racing. Now, I invite Mr. Jim Cantrell to deliver his keynote lecture. Over to you, sir.
Yeah, thank you very much. I appreciate you guys staying into the evening here to hear me. It's morning time here in Arizona as the sun comes up. So glad to be here and thank you for inviting me. I'm going to use a slide deck here, and just a second. All right, can you see that okay?
Yes, sir, we can see that.
Great, thank you. So what I'm going to talk about today is what I see as the future of space transportation and where I think we are in it and where I think it's going. What I tell people when I'm talking about Phantom Space, which is a space transportation company, not coincidentally, is that to me right now, the future space economy is really a very, very infant economy. It's the very, very beginning of something very large. Much like the New World was to the Spaniards in the 1500s, some hundreds of years ago. At that point, if you were standing on the shores of Spain, you might see the Spanish galleons going to and from the New World, and you might know that they were bringing gold back, but you would have no clue as to what the actual future economic potential of the New World was. And we can see now, after trillions and trillions of dollars of value generated in the New World, how absolutely large and influential that economy has been on the future of humanity. I think space transportation is that Spanish galleon going off to a similar kind of place that we, as of today, have absolutely no idea exactly of what will be there and how we will create value and how we make money off of it. But it's clearly a destiny for humans, and we will be a part of that. All right, let me see if I can get, there we go. So I'm going to start with something old. I'm going to talk about the New York skyline in the late 1800s. If you've been to New York City, you know that it looks quite different today. This is what it looked like over 150 years ago. And you'll notice that there are not very many buildings that are very tall. And one of the reasons that is because there are no elevator technologies in this time. And the buildings were pretty much limited to 3 and 4 stories, the amount that humans could easily walk up and down. So by this point, however, you can see that the island itself was fairly crowded horizontally, but vertically it was very short. And what it looks like today is quite different. You see that it's grown vertically. It's also just as crowded horizontally. And the technology that enabled this was elevators. And essentially what elevators did in New York City was to expand the real estate vertically. If you think about it, the amount of floor space that's in each one of these buildings has doubled, tripled, quadrupled the amount of space that humans can exist and work in the city. And so this is a very fundamental transformation of the New York skyline. So in my way of looking at the world, the launch systems that we're working on today really are the future's elevators. And they are the thing that will transform our terrestrial existence into the equivalent of the New York skyline of many, many other places we can live and work and create value. So I think at space commerce, even though we don't know what it is, it's clear that it's going certain directions. What it's going to be tomorrow is anybody's guess at this point. If we all knew that, I guess we would maybe be in the stock market and betting on those things. But what I can tell you is that today it's a very hardware centric economy. It requires a lot of capital expense. To start a space company is almost always more than $10 million today. And it takes you years to create a new capability. Tomorrow, the vision I see is that it's becoming like the rest of the tech economy, software centric, and that will lower the capital expense required to fairly reasonable values, much like the terrestrial economy. And as a result of this, we will be able to deploy new capabilities in space in months rather than years. So this is an optimistic view, I think, but I think it's clear that this trend is happening. And once this happens, you'll see more and more people around the world becoming involved in the space economy. When I got into it 30 years ago, it was, for all purposes and intents, a boys' club, where it was a small group of people who had a very specialized tribal knowledge of how to make these things work. And you were admitted based on your education and your workplace. And it was the thing that we always looked for was an ability to be on a project and get something flown. Whereas today, you see a lot of the graduates of the universities and so on going out and starting their own space companies and just doing it. So rather than having to join the club, and that will draw in more and more people as we go forward into the future and spread both the value creation in space, but also how many people participate in it. So I see it as a very bright future that way. So right now, what we have happening is a disruptive technology we call Microsats. And in the past, we've had very large satellites. This is a geostationary satellite on the left. You can see it roughly in the scale relative to a human. They weigh as much as a large bus that you might ride around a city on, and they cost lots and lots of money, hundreds of millions of dollars, and they require very large launch systems and typically take 4 years to develop. But now we have microsatellites, which you can buy parts for on the internet. You certainly can't buy parts for the large communication satellites on the internet. But this has become something that's very inexpensive because of the supply chain. They're small compared to the human scale, and they're also much cheaper. I've seen some of these Cubesats being built for as little as $10,000, and typically built in a very short period of time. So this is becoming very disruptive. The latest numbers I've seen just last week were 35,000 satellites over the next 10 years are going to be flown. This compares with, say, 20 years ago when we might have 30 satellites in the entire year be built and flown. So you can understand that disruption from that. We have, as part of that, the size disruption, and I won't say that size has created these great numbers, but on the other hand, it's been a rule of thumb in the space industry that every kilogram of spacecraft costs you $10,000 to build, and that's a fairly reasonable approximation. And so based on that, people are building much smaller stuff because it's cheaper to launch and cheaper to build. And you can see here the proliferation of satellites back in the 90s. You had very, very few that were below 1,000 kilograms. In fact, when I first got into this business, small satellites were considered to be 1,000 kilograms or less. And really now what we're talking about is microsats in the 10 to 100 kilogram range and Cubesats in the 10 to 1 kilogram range. And you can see how this is continuing to proliferate. Future projections of this show an even stronger proliferation. And the other interesting thing about these data is you see this top line here, sort of that's formed by the top of the dots here. That's geostationary telecommunication satellites. You can see they've gotten bigger and bigger over time as the launch vehicles have gotten bigger to take them there. And you can think of geostationary space being, much like a beach on Waikiki or any place where a lot of people want to be. It's very limited, high, expensive property. And so like Waikiki in Hawaii or Honolulu in Hawaii, you can imagine why people build skyscrapers there, because they want to make the most money off of limited real estate. So the other thing is that the commercial satellites are starting to be made by the hundreds. This is Planet Labs' image of their factory in San Francisco. This is in downtown San Francisco on 2nd Street. And this is an example of how many satellites they might have ready for launch. They have launched somewhere north of 400 satellites now. And they've been doing very interesting things with these. They're imager satellites. But some of the first truly mass manufactured Cubesats that I'm aware of. And they are creating what Planet Labs calls a living, breathing image cloud of Earth. And there's an enormous amount of value that can be created from this. Traditionally, observation satellites would fly over a spot several times a day. This swarm of satellites would fly over many spots in various times a day, various kinds of lighting, and get really some unusual and interesting data. And enough of them are happening that you can get some pretty frequent updates on the data. So this has led to the potential to do a lot of things with the satellite imagery data that's never been done before, such as monitoring, the conditions on the Earth and using artificial intelligence learning algorithms to look at things like what's the real oil storage capacity in the world. So you can see that from the top, because the tops of the oil storage facilities drop as the amount of oil in them drops. And, we find out that, for example, in that domain, that not all countries report true numbers. For example, you can also monitor environmental impacts of human activity. You can monitor human growth in the cities. The other thing that we've seen done with these very CubeSats is monitoring places like North Korea. I was involved in this program a number of years ago, where the Pentagon came to us and said, gee, our traditional satellites are being hidden from by the North Koreans, who know when they come over. Can we use commercial imagery to set up a neighborhood watch program on North Korea? At the time, the U.S. Department of Defense was unable to predict when the North Koreans were going to do missile tests or even worse, nuclear weapons tests. And so we put a program together to use this imagery to set up a neighborhood watch program, and it worked out very well. And we were able to track these activities and correlate these activities for less than $10 million. And in the Pentagon, you can't start a program really unless it begins with a B in terms of the dollar amount, billions of dollars. So this was a great success, and it shows how even military activities will be transformed by commercial space. So the other thing that you can say is of these CubeSats, this was LightSail 1 and 2, which was somewhat my brainchild, and I led the effort to build. And it's the only private object or human object that's capable of interstellar voyage using sunlight as a propulsion, or any light as a matter of fact, photonic propulsion, to move out into the universe. It is flying right now in Earth orbit, still operating very well for about 4 years now. But this was all privately built, and it was done with donations from individuals who believed in the idea of interstellar flight. But it just shows you that as this technology evolves, it becomes disruptive in many different ways. We see economically, we see militarily, and now we see in terms of exploration that these are disruptive in every way. Excuse me. The terrestrial transportation, then, let's talk about that for a moment. Typically involves, people walking, getting on buses. You've got trams, you've got water transportation systems, you've got trains, you've got buses, cars, airplanes, and so forth. And this is the traditional view of this. What we sometimes forget to talk about, though, is the role of space transportation on Earth. It is new. It is something that is coming along, but it is becoming, and I think in the future will be considered a core part of our our terrestrial transportation system. So let's step back a little bit again. When I was very young, men walked on the moon, and this, however, in those days was really only something that nation states did. And up until very recently, space exploration or launching of satellites into space was almost universally only things that nation states did. That's changing. This was another major milestone in my childhood, believe it or not. I can remember when the first shuttle launched back around 1980, and this was our entire space transportation system in the United States. We got rid of many of our expendable launch vehicles in favor of the shuttle. And again, the scale of the development of this kind of system was only something that nation states could do. The Soviets also had a similar program. I had the opportunity to actually see the Soviet shuttles, one of which flew, the rest of which didn't. They had a fleet of 4 of them, and they were in Baikonur, Kazakhstan. And obviously billions and billions of dollars spent there as well. So only nation states can afford this. Only nation states could gather up all the intellectual brain power needed to put this together, and so it went. But today things are different, and we see SpaceX, which I had a small early role in, has done amazing things, and they have really done things that the government can't or wouldn't, and has inspired all of us in the process. And I would say it's safe to say that that SpaceX has made space safe for investment dollars, and that capital then has driven even more demand for companies like SpaceX. So you see them really, I see them really as the pioneers in not commercial space necessarily, but the way they've done commercial space. And commercial space has been around easily since the 60s with the communication satellites, but in many ways it mimicked the nation state kind of activities. still very large, still very capital intensive. And to do risky things, you actually have to bring the capital investment down, because risk disinvites capital and lower risk invites capital. So we've hit that inflection point in the risk versus capital curve, and a lot of that is due to SpaceX and what they've done. This is the double landing of the Falcon Heavy boosters. Not only was this technically magnificent, it was a showmanship of high order. And I remember watching this about 5 years ago, as it happened, and it was something that brought a tear to my eye just to see this. This was a major event, I think, for this industry. So, the other thing that private industry is now doing is in this country is the human transport. And we saw just about a year ago, the first astronauts launched on a privately funded and built rocket. And that was something that was unthinkable some 10 years ago, maybe even 5 years ago. Most people didn't believe it would happen, but we watched it and we witnessed it. And what a magnificent achievement for SpaceX. So tomorrow, we're already seeing this, that private citizens will be going into space, some for the sheer pleasure of it, some on their own private scientific expeditions, and some maybe even searching for a new place to live. And yes, people ask me all the time, do I think SpaceX is going to Mars? And the answer is absolutely yes. I can tell you in the very beginning, one of the reasons Elon called me was to look at Russian rockets for ideas he had to invigorate this idea that humans could go to other planets. And that was really the main reason behind his wanting to get into the space business. And as we worked together, we worked on a Mars mission that could put a plant on the surface of Mars to inspire the idea of terraforming Mars from a dry, barren place to a green place that maybe has flowing water on the surface and so on, by creating plant life on the surface that consumes the carbon dioxide and produces oxygen. So there is no doubt that Elon's intent has always been to go to Mars as a so-called backup to Earth, and I think we'll see it probably in my lifetime, where SpaceX will go. So this is always what I imagined the future to be, the Starship Enterprise. I grew up watching Star Trek, and I didn't see the future turning out as it has, but we all knew at some point, even in the 60s and 70s, that humans would be venturing off into space and permanently living there for some of us. I don't think we're quite there yet, but maybe this future that was envisioned will become true eventually. The problem really is right now with space transportation is launch is hard, especially large launch. And if you launch people into space, the launch vehicles have to be large. You can't cram humans into small cans, send them into space and expect them to live there. If you've ever seen, a Mercury capsule or an Apollo capsule, even in, say, the Smithsonian Museum or any of the museums in the United States, that they are very small. I'm a very large person, and I would get very claustrophobic inside such a capsule and probably cramped. I know after several hours in a car, I don't feel so good. And I have to get out and walk around. I can't imagine, flying in a space capsule that size. So launch needs to be large. And, we need to deploy things like space stations into space. And this is very, very difficult to do financially. It's very difficult to do technically. All right, hold on a second here. So the other part of it is large launch is very capital intensive. You can see here a space shuttle main engine being transported. Just the sheer size of these things is impressive and immense, and everything about it is expensive. And as you know, I mentioned earlier, $10,000 per kilogram. You know, you've got a lot of kilograms here. So these are some of the most sophisticated engines that have ever been built in the world to launch the space shuttle. And we see versions of this now on the NASA Space Launch System and so forth. So everything about it becomes difficult. But where there's a will, there's going to be a solution, I think. So in many ways, I don't find this distressing, because if you look at public transportation systems, they're the same. You know, train, rail systems, the prices start with billions of dollars, and they transport a lot of people. But there's something that takes many years to develop. So there's an analogy here between launching humans into space and the public transportation systems, and the evolution will continue, and things will get better and more dense, and the human transportation systems into space will continue to evolve. There's no doubt. And so for me, the public transportation system analogy works very well. And I think there's a place for space transportation system terrestrially, going from point to point. If you look at spaceship that's being developed in Texas, and I'll just add as a side note, it's an interesting story to watch. It's fascinating how SpaceX continues to fly these spaceships. They build them, they fly them, they destroy them, they build another, they fly them, destroy it. They're learning. This is something no government would ever do, incidentally. The governments are very risk intolerant and subject to public opinions and politics, and could not withstand the sort of public failures that spaceship has been experiencing. Yes, SpaceX can because they've proven that they can do things and they can make things happen. And so you see the public opinion, which really doesn't matter, incidentally, very tolerant of the failures. More importantly, is their investors and their internal management does support this. So, you know, Elon's obviously very supportive of it. So when you watch that, you have to ask yourself, you know, spaceship is so big, what in the world is it meant for? And you know, obviously, launching humans into space is one of the stated goals for it. But one of the less stated goals that I think is really going to be a reality is going from point to point on Earth. If you look at the cost of them doing this, you know, we may be in an era by the end of my lifetime where I can go from Arizona to New Delhi in an hour. And, you know, I could come give you the speech and be back in the same day with a transportation system like this. So it becomes effectively the physical equivalent of our internet, being able to move things around very quickly on the surface of the Earth for very, very economical costs. So I believe that's one of the very, very strong uses of the Starship. So let's go back to something a little more relatable for most of us, which is the automobile. And this is what I call bespoke transportation. It's really tailored to us as individuals or maybe families. And it's more equivalent to, I think, a second class of launch that's evolving. I really see the economics of the space transportation system being balanced between, on the left, we have large reusable launch like SpaceX is perfecting. And then on the right, we have small mass manufactured launch. And so these two economic systems in transportation, I think, will coexist. They're competitive in the sense that, you know, they're all transporting the same thing, much like the automobile and airplanes, for example. But we have a completely different submarket that it will appeal to, but a very large submarket. All right. So I go back again to the turn of the century and a man named Henry Ford, who's here in this image. And he had from the beginning, and he, by the way, he had two failures before he had a third success. Most people don't know that Ford Motor Company it was his third try, and he had this idea that he could produce cars for the everyday person. And if you go back to the turn of the century, automobiles were really play toys for the rich. They were things that only wealthy families could own, that specialized operators could drive. And Mercedes-Benz famously stated that the worldwide market for cars was something like 3,000 vehicles because of the limitation of the skilled driver base. And while that might be intellectually correct, at the time it was massively incorrect in its eventuality. And Henry Ford created a car then that, instead of costing something like 20 times the average person's salary, he created one that the average person could afford and would be less than a year of their salary. And this was the Model T. So through mass manufacturing, which it's really almost difficult to believe that nobody had come up with this concept until the early 20th century. Henry Ford really put mass manufacturing into play and really built all of that infrastructure that became the automotive industry. And the concepts were rather simple. All the cars were made pretty much the same. And they were, his famous words were, you can have any color you like as long as it's black. They were made on a rolling assembly line. Each worker who would assemble a part of the car acted in a capacity where they did the same thing over and over again. So they became experts at, for example, putting the lights on, or experts at dropping the engine in, or experts at bolting the front seat in. And that's what they did all day long. And so as the next car arrived, the person would bolt the seat in, and etc. Next car, and so on. So as a result, Henry Ford discovered what's called the learning curve, which found that each successive car got less and less expensive, and you could provide these cars at a very affordable price. Most of the new automobiles you go out and buy right now for, say, $20,000-$30,000. If you bought the first unit cost from say Ford Motor Company, that would really be $100 million car or more, and that cost has been amortized over a large number of units, and therefore has become a lot cheaper so that we can all afford it. The same thing is happening in space, and that's with our next generation of micro launchers. You may wonder why everybody is focused on small launchers. The idea is that it holds promise, has yet to be proven, frankly, but it holds promise that it can be as inexpensive on a per kilogram basis as large launchers. It turns out large launch vehicles are very efficient economically, and you can get, for example, with the Falcon 9, down to around $3,000 or $4,000 a kilogram for launching objects into space, but you have to buy the whole space. And so that's either a lot of microsatellites or a very large satellite. With micro launchers, we think we can get down to $1,000 or $2,000 per kilogram, and be able to do it in much smaller packages that become relevant to a customer or satellite operator who would like to deploy a smaller constellation or single unit small satellites and so forth. So the Electron is really the only one that's flying right now. It's built by Rocket Lab in New Zealand. Had some involvement early on with these folks, a very talented group. There's other companies such as Phantom. I'm one of probably 5 or other companies that are doing this, and will be coming online in the next few years. And we all have competing ideas about how to do this, but I can tell you I'm one of the few who are really thinking about how we do mass manufacturing and mass launching of these launchers, which I think is the other next problem to solve. So really, when you talk about small versus large, you've got a number of different characteristics that you have to think about. The small launch can be low cost if you can do enough of them, and the reusable launch, even if you don't do a lot of them, there's fairly low cost because you're just launching a lot of mass. But they tend to be low responsive because you're fixed to a schedule that in the case of Space Launch System, which is the SLS, the NASA vehicle, they're planning on launching that once every 2 or 3 years. And so you got to wait around for that. But if you're doing high rate launch, it may be a launch a week out there, and you can jump on the bus when it suits your schedule. So these are the kinds of things you have to look at. And one of the reasons why really the market is going to the right on this chart into high rate small launch and then reusable large launch. So the other thing of going down in scale is the development costs exponentially reduced. So you can kind of see some of the small launchers from the Electron up to the SLS, how much physically different they are. And the Falcon, for example, was about a $500 million, about a $500 million development cost on that, whereas the Electron was closer to about $150 million. And you can see just the difference on that. So it's a lot easier to raise the capital for the small launchers as well. And the capital is willing to take bigger risks on that. So that's why you see a lot of innovation happening in that area. So I talked earlier about how small launch can match the large launch cost efficiency. Typically, large launch is between $2,500 and $7,500 a kilogram. And although nobody buys on the kilogram basis, they look at absolute launch price. It's a measure of efficiency. So as you watch this and you see that you can get up to 100, 200, 1,000 kinds of launches, you can get not only competitive with large launch, but even more competitive if it's the right size. And so that's the real competition that's going to happen in the future is how do we get to the point where we've launched several hundred of these, maybe even several thousand of these, and can be even more cost competitive than large launch. And that's where the winners and losers are going to happen in this industry over the next decade. So, when you talk about mass manufacturing rockets, people think of, and I even use the Henry Ford analogy. They think of, millions of these coming out the door. And what we're really talking about is hundreds of a year. We're not talking about even tens of thousands a year. And, the analogy I use again is automobiles. If you look at how Maserati did it in the 60s, which is the way rockets are built today, the large ones, they would build hundreds of cars a year. That was it. And I think it was 1972, they had about 400 cars total. They came out of the factory. Today they're in the tens of thousands, not quite up to the millions, but they have a fundamentally different way of doing it. In the old days, they would have one car, one person that would build the entire car, and it would sit in one place. And when that was done, it was done, and it would go out the door. Whereas today, they've converted to a Ford style rolling assembly line. That's really all we have to do to micro launch is to convert to something like that. So the launch manufacturing is actually easy. The manufacturing part's fairly easy. It's all about process engineering. It's about manufacturing engineering, design for manufacturability, and getting enough factory capacity and people, skilled labor to put it together. It's not a particularly difficult problem. The real problem is the launch infrastructure, the launch sites, and where we can launch from. So right now, the way public safety is treated in the United States and most of the world, I would say, is launch is done from very remote sites away from people, and maybe not so much in Florida anymore, but it's definitely launched out over the ocean where there are less people. And in the case of non-SpaceX flights, typically the first stage is dropped into the ocean and never recovered. Whereas SpaceX has started to recover that stage through return flight. There's some interesting things that happen. If you start thinking about launching hundreds of these a year now, first thing you start thinking about is what do 100 floating boosters in the ocean do to the environment? And you can think of a lot of things, but none of them are really good. The other thing is the national security implications of hundreds of these boosters floating out in the ocean. Again, none of those are good. And then you start to think about the economics of it, and certainly if you're reusing the stages, that's better. So I think the future will be almost, even the small ones, almost all of them will have a reusable first stage. Even the Falcon 1, by the way, we plan to reuse. And that's part of what I worked on, was the parachute system to recover the first stage. And those first few flights, the recovery didn't work out so well. That's why SpaceX transitioned to the landing leg concept later on. And I can tell you that the only way that we'll be able to launch a lot of rockets in the future will be to grow away from the traditional federal ranges such as Cape Canaveral, Vandenberg, wherever in the world where rockets are licensed to launch now. We'll have to expand those numbers of sites over time. And really the only places that are likely to be able to launch from is not just over water, but over maybe a desolate, low population territories, such as southern Arizona, where I live. And to do that, really, though, you'll have to have a returnable first stage so that we control the disposition of that asset. It's in fact no different than an aircraft. You watch a 747 fly out of Tokyo, for example. You have hundreds of people aboard a vehicle that has tens of thousands of gallons of kerosene and a very flammable liquid, and flying out over millions of people, literally over the houses, and we don't blink at it. But yet a rocket, which has often a whole lot less explosive capacity, flying out over the ocean, people get all upset about. So as space becomes more normal and we can recover the assets and do it reliably, then the comfort level with flying these, say, out of Kansas, out of Texas, out of Arizona, out of other places in the world where there's not a lot of people around, will become more and more tolerant. And eventually we'll see rocket launches from all sorts of places in the world once we can reliably recover the first stage. So the other thing you can look at for adoption of this small massive launched capabilities, what I call micromobility. And if you live anywhere near a city or been in a city, and COVID's put a dent in this, I'm sure. I haven't been out since COVID, to see how this is going in the cities. But as a pre-COVID, this was a very rapidly adopted technology where you can ride these scooters from place to place and just drop them off. You put your credit card in it, and then you drop them off at your destination. And then there's a system that picks it up. And really something we had never imagined until recently. And I remember going to an automotive conference in Germany about 4 years ago, and somebody predicted the massive adoption of this. And this was just as Uber was starting to be adopted worldwide. And, I honestly, I couldn't believe this, but the truth is that it did. And, we watched as e-scooters and that the adoption rate just went through the ceiling very, very rapidly. It's much more than car sharing and bike sharing and so forth. And so one of the things that's interesting is as to why that happened. And so as you look at the data and you look at the industry, you start to find out that the e-scooters were able to expand their presence and have such a high adoption rate due to two factors. One, the very low capital expense required for somebody to start one of these companies up. And number two was the ability to scale the numbers of these very rapidly. So the second part requires a supply chain that allows the number of scooters to be built to be high. So you have lithium batteries, which we all know have become very common in our life, along with the scooters themselves. The hardware and the computer and the software that go with it is readily available. So between that and the small scale of the hardware, which made them cheap to build, they proliferated and people adopted to using them. So what we're starting to see, and this is the analogy with the small launch, is to me, they're kind of like the e-scooters. They've got all the same attributes. We're starting to see the supply chain, the small launch come along, and the relative affordability of it relative to the big rockets is quite high. So while they're not quite the price of e-scooters yet, I think the analogy still holds very nicely. So what we'll end up with is a new transportation model of $1 million to $4 million per flight, and flights of 100 per year, and that'll fundamentally change the economics of the space industry, and it will change the way people create space companies and deploy space companies. It'll change the way governments use space. It'll change the way space is accessed completely. And this new transportation model will not displace large launches in the tens per years. It'll merely supplement them and facilitate and fuel the growth, I believe. So, ultimately, we're at the very beginning of this competition of small launch vehicles, but hopefully you understand a little bit better what role they play in the future of space transportation. So, yet I'm going to start talking now about something much bigger, which is how humans are going to move out into the cosmos. And first, it's kind of important to understand at our core, we're still a very wandering species. We all possess some amount of curiosity about what's around the next corner, what we have ahead of us. Are there better places to be? This is what drove early humans out of the birthplace of our species into better hunting grounds, ultimately around the world, to places like India, to places like North America, and so forth. And it's what drove the Europeans away over to find the quote new world unquote, and settle that and create what has become modern day America. And we're going to do the same thing in space. That's because this is what we do, and this is wired into our DNA. It's part of who we are, and we can never deny it. This is why movies such as Star Wars and Star Trek are so powerful and so popular, is that it touches that part of our DNA that we all have, some more than others, but that we all ultimately respond to. And so I say that our most important revolution in space has begun, the human movement into the cosmos. And this was this famous shuttle backpack, but it represents man alone in space with a small machine that I think is representative of the future of our species in space. So, like we settle the new world here in North America, humanity will move into space and become a permanent resident there. It may be in my lifetime, it may be in your lifetime, or it may be in our children's lifetime, but it certainly will happen. I'm becoming more and more optimistic that it will happen sooner rather than later, which is very exciting to me. One of my first jobs in this business was on a Mars mission, and I spent a lot of time imagining what it would be like on Mars. We were building a balloon to float on Mars, and of course, you have to imagine, what is the surface like, that we have to contend with, and what would the cameras pick up, and what would the panoramas look like. So the idea of humans actually going there and seeing this is tremendously exciting for me, given sort of my historical interest in this sort of thing. And I think it's one of the few things that actually brings all of us humans together, like the Apollo missions. That was a human triumph, not an American triumph. It was an American triumph, but it was more a human triumph. And I think the same thing will happen with Mars. So it's rare in this day and age, in any day and age actually, to have something that we do as a species that actually brings us together as a species. So that's the other side of this that excites me. And when we first started talking about this, in fact, I can't say we started talking about it when I got into this business. I inherited the discussion. It had been going on forever, about how we go to Mars and how we send people into space. And it was always something when I was early in this business, we would complain about NASA can't do this and NASA won't do that, and NASA needs this and NASA needs that. Well, most of us that got frustrated by that early in life got pissed off, and we just went and started doing it ourselves. And it's really the motivation that started SpaceX. It's really the motivation that's led to a lot of what we see now in private space, that we're just tired of waiting around for governments. And in fact, governments can't do it alone. And the only reasons governments did it in the beginning was that there was a strategic need for it, and they could afford it. And really, in a lot of ways, it's a creature of the Cold War that got started, the lunar missions and so on, the competition between communism and capitalism and so on. But today it's a different story altogether. And governments are really just an end user of space rather than an entity that develops it. So I think it's important to understand this and to recognize that they're not ever going to be the solution to it. I call it the Halon strategy. As I looked at this at this government dominance of the industry, and I wanted to change it, there was a lot of ways you could do it. You could try to take it on and destroy it and replace it, and that's a fool's errand, because government protects itself. They won't give up what they view as their rightful role in this business, and so on. So instead, you create the equivalent of halon. You just take the oxygen away, and it withers and becomes something that survives the new conditions. And you do that by creating what we have today, which is a private sector that moves so much faster than the government ever did, that they are forced to just adopt it. So the other thing that you have to think about is, as we move into space, the military is going to come along with this. This is the not so pleasant side of our move into space, but it's inevitable. There's a lot of people who are philosophically opposed to it, and I, like a lot of people, are philosophically opposed to war completely. It's a very wasted activity. But on the other hand, it's a natural byproduct of our disagreements and our sociological makeup of our population. So the reality is that the military will always be ready to do battle in space, and that we just simply have to contend with this reality and deal with it. So it's not something I think that will slow us down per se, but it's a reality that will consume a lot of the resources that might otherwise go into space exploration. And in many people's eyes, it's a necessary diversion. But I'm not here to argue that. I just want to point out that this is something that will go along with us, regardless of whether or not we think it should be there. So the rest of the world, really is unable to deal with a lot of these realities, particularly at a government level, like I was saying. So private enterprise will be the ones that take us to where nobody's gone before. In many ways, the New World exploration was privately financed by the Queen of Spain, and in many ways it was the same sort of thing. Ultimately, it was Spain, that started to explore the New World. But as you start to understand the history of the New World's exploration, there were a lot of private companies that would come there. The pilgrims, the famous pilgrims that came to the United States in the 1600s, actually weren't the first ones. They were preceded by these trading companies that would come looking for beaver pelts and woods and things like that to trade. And in fact, my ancestors came here in the late 1500s. I'm one of the oldest families in the United States, and they were here as merchants. and they weren't here as representatives of any government. And the same thing will happen in space. So it's hard to imagine, just like, a couple of wooden ships going across the ocean to the new world sparked an entire change in our history. This is what SpaceX looked like. That's Elon's McLaren down there in the left-hand corner. This was our first factory in El Segundo, and this is how it looked like when we moved in. And I remember arguing with Elon over the cost of painting the floors with epoxy paint, which in my mind you had to do, right? There was no alternative. But this is where SpaceX began. And so you might not, as you go out and survey the rest of the space industry or any of these budding industries, you may not recognize these things that are the beginnings of something enormous. But this is what it looked like. And to me, it just tells everything. I remember sitting in the offices, which were over behind the left wall over there. And I remember looking out the window. I couldn't get the network to work, and I couldn't, hook up to the internet. Even back in 2002, that was fairly important to what we were doing. And I saw a rat run across the floor here, and I thought, really, we're going to build rockets here? Even I didn't have the faith that we would do it. But Elon saw things that none of us saw, and just like this picture is so symbolic of that. We've got to keep our eyes open, and the rest of the industry, to spot those things that are coming. They may not look at all like what the future looks like. So keep this picture in mind as you think about it. So here's what they build now, and it's just to connect these two is almost impossible in a person's mind unless you know that it's a fact and it's true, and that you've seen the story. But to go from here to here is just mind-boggling, and this is in less than 15 short years, really, in human history. It's not long. So this gives you a sense of how rapid the pace is here. So I think that it's safe to say that the first humans to Mars will come by private taxi. They won't come by government black Suburban. They'll come, they'll stay and live off the land. We all watched the movie The Martian, and I know the author of that. It was originally just a sort of an off-the-wall book that Andy Weir wrote, and that it got adopted for the movies. And it's a very technically accurate story of using greenhouses. And again, this was the kind of greenhouse that Elon was talking about landing on Mars. That's why we went to Russia to buy rockets. It was a much smaller version of this, obviously, but the same concept holds, right? There's no reason we can't go to Mars and create an environment where we can live off of. Maybe some of it's underground, maybe it's all above ground like this. But the point is, we'll innovate and we'll figure it out. And if we could just get the stuff there, we can figure it all out. And I think this is something that is terribly exciting. I think it's only the precursor to much bigger things that look a little bit like the Enterprise and so forth. So at any rate, this is I think a very, very fundamental part of our future. So the other thing I want to sort of point out to you is, I can tell you who the most famous human ever is, even though this person has probably not been born, definitely not been born, and we don't even know who this person's parents are. But this most famous citizen ever will be the first human being born not on Earth. That has never once happened. And once that happens, we've reached a new milestone in who we are as a species. And no doubt it will happen. It's just a matter of time. So we are really just in the very infancy of this whole thing. And there's so much to do here and so much opportunity here. It's mind-blowing. It's something that really requires the enterprise of the entire of humanity to accomplish, and I'm confident we'll do it. So ultimately, this human achievement will be not a government program, but it'll be human achievement. It'll be something that we can all be proud of, it'll be all something that we can feel a sense of liberty from, having done it this way. I can't think of going back to the mentality of the 80s and 90s, thinking that the governments have to do this for us. So I want to plant the seed with all of you out there who are listening that it doesn't matter if you're American, Indian, Pakistani, French, British. I don't care. This is a human endeavor, and we will all achieve it together in one way or another. And it's going to take all of us to do it. So this will conclude my talk. I want to just leave you with the image of a Starman, which is a real car, and a dummy. This was Elon's Tesla that he launched on the Falcon Heavy. Very typical of Elon's sense of humor, but very symbolic of what he's trying to do. So I thought it was brilliant. I thought this is one of the most brilliant things I've ever seen, is launching a Tesla into our orbit. Well, actually went to Mars, actually. So any rate, all of us go to the stars. We're all made from the stars, and to the stars we return. So thank you very much. I don't know if anybody if we had a Q&A session or what, but I'm
Yes,
happy
sir.
to hang around.
Thank you for that inspiring talk, sir. Giving analogies with automobiles, and that motivating lecture was awesome. We have some few questions, sir. Yeah, can you share a few of your memorable incidents working in SpaceX? You shared the humble beginnings, right? So
yeah, some more. Well, the stuff you can read on the internet covers our trip to Russia. I'll leave that one alone. But yeah, let's talk a little bit about the early days of SpaceX. In that picture you saw, we were a very small team. It was a team I'd put together to do the Martian lander. Really was the core team. It was Chris Thompson and Tom Mueller and Hans Koningsman and a few others. But basically that was it, to design this rocket. And Tom had the engines, and I was in charge of a lot of different things, contracts and the parachutes and so forth. And Thompson was he was doing the mechanical design of the rocket, and Koningsman he was doing all the software and the guidance, navigation, control, and so forth. So it was a very very small group, and this floor behind the offices was much like that. And we had our own little laptop computers, and that's wouldn't be any different than any other startup you'd see today. And we had all the same troubles of couldn't get the internet to work. I remember the front door we'd use. This was in El Segundo, California, which is very near Los Angeles Airport and LAX. And we'd leave the door open, and we'd have homeless people walking in the front door. And we eventually had to lock the doors, but it wasn't in a great part of town. And so it was very frustrating in the early days, I would say, to think that we were going to build this rocket. And I didn't have insight into the raising of money. That I was trained as an engineer. This business of raising money I didn't learn until much later in life. And of course Elon knew it because he'd been through it with PayPal and so on. But I didn't have that benefit. So that was one of the things I lacked. Was I understood how much money this was going to take, but I couldn't see how we would come up with that money. So that was like a completely foreign thing that I didn't understand its existence of. And so as time went on, it's obviously we're able to raise the money. And I would say that back then it wasn't as developed either as how you raise the money. But it was one of those things that caused me to wonder about the viability of SpaceX. And Elon was not always there either. He was he had an office upstairs, and he had an office where it was just a cubicle, and anybody could come and just grab him, and it was very accessible in those days. As we added a few more people, he had an assistant, Mary Beth Brown, and I really liked Mary Beth. She was very helpful to him, but I wouldn't call her an admin or anything like that. She was kind of a personal assistant, and sometimes you'd have to talk to her to get Elon's attention. He was always on the phone, but he was very involved in the decisions. He's very technical, very smart, and he's smarter than all of us. I'll admit that. I think his IQs exceeds all of us by far. It was apparent from the beginning. I'm considered pretty smart, but compared to Elon, he's a whole other thing completely. But the thing about him that I found was he was very motivated, and he would spend so many hours at this. I don't necessarily know that that's the formula for success, but Elon certainly did spend the time at it. And I can remember a few times getting phone calls at 3 a.m. because he's still working. I'm sleeping, but he's working. And I was never the guy who worked 20-hour days or anything like that. I get to 12 and I'm done. Elon would get to 20 and he was done. I don't think he slept very much. And so part of his success is this. Part of it is the fact he just doesn't give up. And I think that's probably the bigger part of it, as I saw from the early days. And a lot of us were getting discouraged because of the conditions of not having internet, and it was these shitty little desks that we were sitting at, and it just didn't meet our mental expectations of what a big rocket company would be. And having not seen this go from that picture that you saw to the other picture of the rockets going out the door, it was hard to believe in it, right? It was a little bit like believing in God, maybe. So we just didn't have that faith, and a number of people stuck with it because they had to, and it turned out very good for them. Of course, people like me, I didn't have to, and I left because I got tired of all the things that I didn't like to deal with, like the 3 a.m. calls with him yelling at me and so forth. And frankly, I wasn't into the idea of what Elon wanted to do. I just didn't believe in what he was doing at the time. So I went off and did my own thing, and I rationalized the money side of it and said I could make as much money on my own. I made a lot of money on my own, but not as much as Elon's made. So clearly, I could have stayed, but I would have had to have been a different person, frankly, to have stayed there. And at the time, I had family, I had young children, and they needed me, and so I chose a different life that kept me closer to my children, where I could raise them and be a part of their lives. And I don't regret it. So it's okay. But I do think a lot about it. And I think back on, the choices we make in life and how small choices have big consequences. And that's kind of an interesting thing for me to think about. Again, I say I had a small part in a very large enterprise in the beginning, and probably influential, but it's definitely a small part. And I like to think that I help change things in that respect.
Thank you, sir. Thank you so much for that answer. What do you feel about electric powered rockets? Like, what is its feasibility in the future?
Electric propulsion, is that what you said?
Yeah.
Sure. Let me just say, on a larger scale, propulsion is one of those things that has to improve for all those things I talked about going into the cosmos, right? And I think propulsion systems today are still like engines were for the Model T, right? Very primitive. And chemical propulsion's fine, but it's very inefficient, and you have to take so much mass with you to go anywhere. We have to find a better way in order to go beyond Earth and to go at speeds that we don't die by the time we get to our destination. So really what electric propulsion is a step along the way, but it's certainly not the answer, because it's not that much more efficient. Plus, The problem is it's very difficult to get the kinds of thrust levels up to get to the points where you can get the kinds of speeds we need in a reasonable period of time. Don't get me wrong; it's a great technology. At Phantom, we have electric propulsion we built for satellites, but the issue is really it's not going to be the ultimate solution. It's a stepping stone. So my gut sense is that there's probably something that is more based on quantum physics and things we don't understand today that will create propulsion of the future. Antimatter propulsion, for example, that will create the kinds of things that'll propel us to the stars. Electric is going to make what we do in space more efficient, but getting from the Earth to space serves almost no purpose because of the low thrust.
Yeah, thank you, sir. We have few more questions. What are your views on reaching some planets outside the solar systems with our Earth? Like what are the feasibilities near future that we can achieve that?
It's a great question. So one of the people I had the honor of knowing in my life was Carl Sagan. He was a famous astronomer. Maybe some of you have seen his series Cosmos. And when I was a young boy, I watched Cosmos on TV, and got me interested in science. And when I was living in France, he called my house. He was in town. He was in Toulouse, and the phone rang, and it was this familiar voice, and he was asking for me to give him a tour of what we were doing with the Mars balloon. And so I did, and we got stuck in traffic. And Carl was very impatient about a lot of things. He didn't like traffic too much. So we got talking, and he asked me. He said, "Jim, are you a man of religion?" And my answer was, my life would be a lot easier if I were more so. And I said, I struggle with it. And I struggle with faith. And he said, he says, who has more faith? He says, you look up in the sky, and the scientist sees these dots of light with millions and millions of dots of light. And you imagine creatures living on each one of those dots of light. Or somebody who looks around this earth and says, this is a place of beauty that was obviously created by a God. Who has more faith? And I said, clearly the scientist has more faith, right? So it's an act of faith that's based on our intellectual understandings of these things. And yes, I believe that we do absolutely have life elsewhere in the universe. We may have life on Mars, frankly. I'm not convinced that we haven't truly discovered that. It will be in a lot of ways, I hope that we don't, because if we find life on Mars, it'll be very complicated about how we explore Mars, and all these great pictures of people living on Mars or even going to Mars will be greatly complicated. We've seen what this virus called COVID-19 has done to us. Can you imagine the idea of a non-planetary virus coming back? So this reverse contamination of Earth. So in many ways, in our solar system, I kind of hope we don't find it, but on the other hand, I do hope we find it. But clearly out on the stars, there are other planets like Earth that have habitable conditions. In fact, I would dare say that life, as we understand it, as a carbon-based life form, is only one of many different kinds of life forms that might exist. So there may be other conditions, like we find life at the bottom of the ocean now when we go to new places. There are things down there that we never thought existed near sulfur vents and so forth. Same is going to happen in the universe, and that's the magic that that sparks my DNA to think about what's really out there, right? And if only we could go there.
Thank you, sir. Thank you so much. In your view, when can we see the future like space transportation affordable for a large number of population?
Yeah, I think so. I look at what we're doing. Again, I think the answer is mass manufacturing. And I think if we build enough of these things and we can figure out how to launch rockets from places that aren't Cape Canaveral and Vandenberg Air Force Base and places like that, it's going to be very affordable. Maybe not for the average person, but it'll become more like aircraft transportation was, 100 years ago. And now you look at, almost all of us can afford an airplane ticket to go somewhere else in the world. So, we're looking at the possibility of human transport on our small launch vehicles, for example, as part of the future transportation sector. It doesn't necessarily have to be a Falcon 9, which is always going to be $40-50 million. But if we can get, our launches down to single-digit $1 million, that's accessible to a whole other class of people. And if you start reusing these systems, then again, it becomes even more affordable. So, yeah, I think the future is very bright there. And maybe even within my lifetime, we'll see that. My life's what's left is shorter and shorter, but you're much younger than me. I'm sure you'll see it. Maybe even you will be able to go into orbit, and then after you're done, drop into New York City when you're done.
Thank you so much. There are a few questions. For a given type of launcher, what is the difference between the cost to orbit if we have an object sending to orbit or a human? What is the primary difference between both, and what are the challenges in each?
That's a great question. So I would say a rough order of magnitude difference in cost is probably a factor of 3 or 4. And the main reason is just the safety of, we at least in most countries in the world, we consider life somewhat sacred. So we don't necessarily want to endanger it unnecessarily. So we have a higher reliability and a lower tolerance of failure. Therefore, there's going to be more attention paid to that, more money spent on it, and so forth. So, the big differences between a human rated system and a non-human rated system is the number of levels of redundancy in the technical backups and so forth. You typically have a triple voting system on all the software, and you might have physical redundancy on that level for the hardware itself. I know on the shuttle, they had at least 2, preferably 3 systems for everything. A lot of spacecraft you see that are unmanned often will have, full redundancy on all the avionics and so forth. The power systems, they generally don't. And so there's some things you can't have redundancy, like on a structure, on a rocket, you can't have redundancy on that. You only have one structure, but you might have something that's built a little sturdier. It's got more safety margin into it. So those are the sort of things you look at. It's a wide variety of things it impacts, and but fundamentally it's the same device, right? And you see the Falcon 9, the human rated Falcon 9, they had to spend a lot of development money on that, and so that's the other side of it, is that development money has to be recuperated through an increase in the pricing. So, the numbers I'm seeing for some of these private flights of astronauts to these private space stations, again, it's an early market, but I'm starting to see $50 million a passenger, which seems very high to me. So, I think, Virgin, when they talk about their trip to space, that's actually not to orbit. It's energetically a lower amount. You go up, you experience 15-20 minutes of 0 G's, and you come back, and that's hundreds of thousands of dollars, up to $1 million. It's not 50 million. So we'll see. Again, with the small launchers, I think they give us a chance of having single-digit $1 million human trips to the space station rather than $50 million, and that'll be through mass manufacturing.
Yes, sir. Thank you for sharing your thought. We have one more question. We always have this quality and cost issue, right? So in all the transportation things. So particularly in space transportation, what do you think? If you develop partnership between space agencies of companies, would you vision reduction in the cost and what quality could be, what sort of quality issues could be solved by having partnership between companies?
That's an interesting question. How could we, partner between companies? I think what's evolving is a supply chain, which is kind of what you're describing in this industry. It's, SpaceX was what we call vertically integrated. They build everything. Literally, there's very, very few contractors to SpaceX. A lot of people, over the years, I get a lot of people asking me to get introduced to SpaceX. And just for the record, I don't do it, so don't ask. It's not that I'm annoyed by it. It's just it's not going to work. But they have done that for historic reasons. Number one, 20 years ago, as we looked at the supply chain, it was really related to the military industrial complex, and so we realized in order to disrupt the price and the cost of the business, we had to build all of our own parts of the rocket because we couldn't rely on the basic core costs that were baked into it by the way the government does business. So that's why we vertically integrated SpaceX. The other thing was that we knew that eventually, if we were successful in disrupting the industry, that the large companies like Lockheed Martin, like Boeing, whose capabilities we were actually disrupting, they would resort to political acts to keep us from becoming competitive. So we decided we had to be independent of their supply chain, which they largely controlled because they were doing the most business with them. So it was those two things together that forced us there. What you're starting to see now is a change. It's a maturing of the industry. And at Phantom, for example, we took a completely contrarian view of this vertical integration, and we're buying our engines from another company that has already designed and built them and tested them. We licensed our avionics from NASA. We're buying, the batteries from another company and so on. So we're not doing it like SpaceX did. Almost every launch company that starts does it like SpaceX. And if you go ask them, why are you vertically integrated? They just look at you with this look and they say, well, because SpaceX did it that way. They don't think about it. And the reality is that no industry is built on vertical integration. That's very large and very successful. Even General Motors or Ford or any of these companies, they all have to rely on a supply chain. So I think it's healthy. I think it's one of those things that's happening here. It's in the very early stages of it. But in terms of how SpaceX and other companies work together, by and large, I think that will be Blue Origin and SpaceX will probably never work together because they're competitive in nature. But say some of the smaller launchers and some of the large companies, there will be a consolidation of those companies. SpaceX will probably end up buying a few companies. Blue Origin, the same thing. We'll see that consolidation happen. That's probably about 10 years away. So that'll happen with time.
So we have one quick last questions. Last question, are we going to see space elevators? Is it really possible?
So I'm not a believer in space elevators. Arthur C. Clarke's idea. I don't see how they practically work, but I've been wrong about a lot of things. So take that with as we say, with a grain of salt.
Thank you, sir. Thank you very much. It was a wonderful session, inspiring talk. I hope all the audience would have got enriched with your keynote lecture. Thank you for giving this lecture in RSD 2021. Yeah. Yes, sir. Thank you very much.
Thank you very much. All right. Goodbye.
Thank you, sir.